Welcome back, guys. We're going to extend a little bit on our graphing for another position time graph, and we're going to do something where we have to choose what our divisions are on each of our axes. And the idea of this is that you want to use most of the graph, but you also want to make it convenient for yourself. So hopefully I'll be able to show you how to do this. Again, we have someone that is walking. I'm going to put down my ordered pairs. I'm going to have time on the x-axis, and I'm going to have position on the y. And I'm going to start at 0, 0. In the first 100 seconds, he's going to end up at 50 meters. Then, in the next 150 seconds, so I have to add 150 seconds to 100 and get to 250 seconds, he's going to be at 200 meters. So I added 150 meters to this value. Then he's going to rest for 50 seconds. So it'll still be at 250. Sorry. He'll rest it for 50 seconds. It'll now go up to 300. Because I'm still adding 50 seconds, but this 200 will stay the same. And then finally, in the final 200 seconds, he'll return back to start. He'll return back to 0. So I want to look at what my biggest value is. On the x-axis, my biggest value is 500. On the y-axis, my biggest value is 200. So my y-axis is going to be my position. And I'm going to measure this in meters. My x-axis is going to be my time, and I'm going to measure this in seconds. You don't need to do any more than just put down what the letter is. In the x direction, my biggest value is 200 meters. I'm going to divide this by how many boxes I have vertically. So I'm going to count them out quickly. And again, graph paper I would give you would have them in division of increments of 5 you can count easily. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6. So I have 200 divided by 26. If I put this in a calculator, I get 7.7. So if I made each one of these 7.7, it would end up at 200 all the way at the top. That's not convenient. So I'm going to round up to the next closest convenient number. And I would say that's 10. So I'm going to make each one of these increments 10. So this will be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 200. So that's the highest that I'm going to graph up, and I have this amount above, but I'm still using a good portion of the graph. On the bottom, I need to go up to 500. So again, I'm going to count over what these are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. So I'm going to divide this by 30. And I get 16.7. Again, not a convenient number, but it would be convenient to round that up to 20. Or even 25 would also be convenient. All right, so I'm going to make this 20, 40, 60, 80, 100, 20, 40, 60, 80, 200, 20, 40, 60, 80, 300, 20, 40, 60, 80, 20, 40, 60, 80, 400, 20, 40, 60, 80, 500. So again, I'm not using all of the graph, but I'm using a good portion. All right, our first order pair for Jebediah is going to be 0, 0. And then we're saying in the first 100 seconds, he's going to go 50 meters. So I'm going to go over 100 and up 50. So this is going to be 100, comma 50, and I'll make a line. So I'm saying again that he is going at a constant speed. So I can find out what that speed is by taking the slope. If you remember, the slope is y2 minus y1 over x2 minus x1. So in this case, it would be 50 minus 0 meters over 100 minus 0 seconds. So everywhere on this line, he's going 1/2 meters per second. In the next increment, he's going for 150 seconds and 150 meters. So now 150 seconds plus 100 is going to go to 250. 150 meters plus 500 is going to go to 200. So I'm going to have 250, comma 200. And again, I'm going to try to connect this with a line. This should be a steeper line because he's traveling more distance every second. I can find out how fast he's going on this increment by finding the slope. And so he went to 200 meters from 50 meters. So 200 minus 50. And this happened from 100 seconds to 250 seconds. So 250 minus 100. So we get 150 over 150 or 1. So we have 1 meters per second. He then is going to rest for 50 seconds. This is going to take me from 250 to 300. So I'm going to have 300, comma 200. And if you remember, the slope of a horizontal line is 0. So for that increment, he's not going at all. And then for the final 300, he's going to return back to where he started. So 300 seconds, he's going to go from 300 to 500, so 200-second increment, and he's going to go backwards 200 meters. And again, to find the slope, they're asking us for the speeds. Speeds are absolute value, so it's only going to be positive. So this is going to be 500, comma 0. So I'm going to have 0 minus 200 meters over 500 minus 300 seconds. And so this is going to give us a value of -1, but we're going to make it +1. The last thing they're asking us is for the average speed. Average speed is going to be the total distance over time. So his total distance is going to be, he went 200 meters forward, he went 200 meters backwards. So he's going to have 400 meters, and this took him 500 seconds. So it's going to be 4/5 or 0.8 meters per second. All right, when we come back, we're going to talk about the next type of graph that we can draw that'll take into account the speeds versus time.